Hello, everyone. Today we're talking about measures of center and spread. In our day to day activities, we deal with many problems that involve related items of numerical information called data. Statistics is the study of sets of numerical data. When we gather numerical data besides displaying it, we often want to know a single number that represents the data as a whole. We call these numbers measures of central tendency. Two most common are the median and the mean. So our mean is always the average, and the median is always the middle value. So, exercise 1. A survey was taken amongst 12 people on the number of passwords they currently have to remember. The results are in ascending order shown below. State the median and number of passwords and the mean number of passwords. So to find our median, we're just looking for the middle value. So there's 12 people, so we want 6 below. Because these are already in order, we know that the median is in here. 6 below, 6 above. So we take the average of 2 and 3 by adding, we get 2.5. So our median is 2.5. Our mean, we're going to add those all together, 29, and we divide that by 12 because there are 12 data pieces. And our mean is 2.4 when we round to the nearest tenth. So our mean and our median in that scenario are rather close to each other. Exercise 2. Students in an algebra class were trying to determine if people speed along a certain section of the roadway. They collect speeds of 20 vehicles, as displayed in the table below. Find the mean and median for this data set. Now we have to be careful because when it says 5 next to this 35, that means there's 5 35s. So there are two ways we can do this. We could have used our calculator on the other one. But since we know there are 20 vehicles, to find the median, we want to find the 10th car. So these are in order. So what I'm going to do is I'm going to say, well, that's 3 cars, 7 cars, and in here that's a total of 12, which means the 10th car is in here, as well as if we go up, right, because that's 3, 5, 8, 9, and 10. Therefore, 35 is our median. Now our mean, we would have to multiply these. So we could do 29, 66, etc. And then add those up and divide. The easier way is we can do this on our calculator. So I'm going to open my graphing calculator. To do this on our calculator, again, we go to Stat, Edit, and I'm going to type the values in. However, I need to type the number of values that I have for each one. So there's 129, there's 2 33s, 39s, and 154. So we've typed our data in, and I can see that I did it accurately because it tells me I'm on spot 21, and I should have 20 sets. So now I go to Stat again. This time I want to calculate. So I arrow over to Calc, and one variable statistics. Enter, enter, enter. So here again, I can use this N as a check because it says N is 20. And our mean is this X bar. So on your calculator, X bar equals mean. And our mean is 36.1. We arrow down, you can see that our median is 35. So now to continue. The speed limit along this part of the highway is 35. Based on your results from Part A, is it fair to make the conclusion that the average driver does speed on this roadway? So it's not fair to say the average person drives. It's that you would say half do The other half do not. Because we have an equal number above and below 35. So I want you to pause and I want you to try exercise 4. So I used my calculator here and I found that my mean is 74.6 and I found my median 74.5. This is not a fair sample because he's using the basketball team, which tends to be taller. So it's not fair to associate that with everybody else. So data sets can have members that are far away from all the rest of the data sets. These elements are called outliers, which can result in the mean that does not represent the true average. In Mr. P's advanced calculus course, 8 students recently took a test. Their grades were as follows. Calculate the mean and median of this data set. So again, I'm going to pull up my calculator. And on my calculator, a couple things here. I want to get back to the main screen. So I can do second, quit. Then I'm going to go to stat, edit, and I want to put new data into L1. I don't want to hit delete because that's going to delete the entire list actually, including the L1. What I want to do is I want to arrow up to L1 and then I want to hit clear and enter. And that erased all that data. So now I can put more data. So I just type those numbers in. Again, I'm going to calculate the linear data. So stat, calc, and I see that my mean, which is X bar, is 80.7, and my median is 85. Now it says, what scores an outlier of this data set? Well, if I look at this data, it's all pretty close to the 80s except for 45. So 45 is an outlier. Then it says, so which value, the mean or median, is better measure of how well the average student did in his class? And in this case, it's the median. And the reason why it's the median is because the outlier greatly affects the median. So we're going to do these additional problems here in class, but I want to scroll down to page 8, where we're going to talk about measures of variation. Standard deviation of a data set tells us on average how far the data point is away from the mean of the data. The larger the standard deviation, the greater the variation within the set. And the interquartile range, which is the IQR, is defined as the difference between the third quartile and the first. So to find our IQR, we do Q3 minus Q1. Our calculator will do our standard deviation for us. So a farm is studying the weight of baby chicks. They find the weight in ounces. The weights are shown below. Find the mean, the interquartile range, and their standard deviation. Round any non-integer values to the nearest tenth. So again, we're going to open our calculator. And I'm going to add those numbers into a list. So I go to stat, edit, and I'm going to clear my first list. If you're going to be reusing problems, you can just do more lists, but in this case, we're only using them each once. So I'm just entering the numbers, making sure that I enter exactly what's written. They do not need to be in order for me. If I was finding the median and Q1 and Q3 by hand, I would start by putting those in order. But since I'm using my calculator, I just enter them in. And I have 20 weights. So then I do stat, calculate, and option 1, enter, enter, enter. And then our mean is 3.7. To find our IQR, we need to do Q3 minus Q1. So our Q1 is 2.5 and our Q3 is 5. So that's 5 minus 2.5, which is 2.5. Now our standard deviation. Our standard deviation, we're going to talk more about down there. And there are two different standard deviations on our calculator. There's SX, which is a sample, which actually is what we should use here because this is a sample of the people. Actually, this is our entire population. So we should use the sigma. So we're going to say sigma x, and it's 1.7. That's our standard deviation when we're using the entire population. Down below here, we say we are working with every possible data point of interest. We call that the population. So we use sigma, and that's what we did here. When we have only a sample of all possible values, we call this the sample S. So that's S sub x on our calculator there. They differ slightly, which is why we're going to get slightly different numbers. So exercise 4. Marketing company is trying to determine how much diversity there is in the age of people that drink different soft drinks. They take a sample of people and then soda they prefer. For the two sodas, we have these two lists. Explain why standard deviation is a better measure of the diversity in age than the mean. So our standard deviation is better because it tells us how far from the mean. And it's not as affected by outliers. Which soda appears to have a greater diversity in the age of the people who prefer it? So we're going to look at the list. So it's soda A because the range is larger. It goes from 16 to 44. C, use your calculator to determine the sample standard deviation. S sub x for both sets of data. Round your answer to the nearest tenth. So again, we're going to use our calculator. So I want you to pause, and I want you to enter A into list 1 and B into list 2. And then we're going to calculate both. So you can see on my calculator here, I've entered both lists into list 1 and list 2. So I'm going to find both sample standard deviations. So I'm going to do stat, calculate. I'm doing one variable statistics, and first I'm going to do list 1, and it's 9.6. So A is 9.6, and then B. So to get B, I go to stat again, calculate again, one variable again, but now I need to change list 1 to list 2. So you can see above the number 2, there's an L2 in blue. So I do second 2, and that makes it be list 2. And there my sample is, or standard deviation is 4.1. So this does support my answer from B because it has a larger standard deviation, which is typical when there's a larger range.